In Lesson 30 in your Friendly Chemistry course, you'll be introducing the relationship between temperature and volumes of gases. This is known as Charles' Law. In the teacher's edition, it recommends taking a partially inflated balloon and then subjecting it to heat over a light bulb. We have an alternative activity here which can provide the same experience for your students. For this activity, you'll need an empty pop bottle, and the larger the pop bottle you can get, the more dramatic your results will be. We just have a small bottle here from drinking water, and then you'll need a source of very hot water. Boiling tea kettle water is ideal. This will have to be an activity most likely you'll do as a demonstration due to the safety considerations of having this boiling water here. And then also you'll need another container which has some very cold water. So what I've done is just taken an ice cream bucket and got a cold pack that I've had in the freezer for a while and just submerged it into some water there in the bucket. And what we'll do is we're going to take some of the boiling hot water, and we're just going to put a small amount in the bottom of our pop bottle here, and then we're going to shake it around in an attempt to heat up the gas that is trapped inside the bottle. And according to Charles' Law, as the temperature of the gas in there goes up, the volume of the gas should go up, and the pop bottle will expand. It'll fill up. Now, if you're using a large pop bottle, that can be fairly dramatic. If you these kind of bottles that tend to make a lot of wrinkly crackling sounds, you can definitely hear the expansion taking place. And then you can pass the bottle around and let your students feel how tight the bottle has become because of that expanding gas on the inside. And then as that gas begins to cool, the volume will again decrease, and you can speed that up by then submerging the bottle into the cold water and then bringing it back out and show your students how the volume decreased there. So let's give this a try so you can see firsthand. So this water was boiling a few minutes ago. It may have cooled down some. So this is where you'll want to be very careful that you don't scald yourself or our students. So I'm going to attempt to just put, maybe a fourth cup of hot water into the bottom here of my pop bottle. I'm going to put the lid on, tightly put the lid on, and then we're just going to swirl it around in there. We're going to warm up the gas inside the container. Okay, and you can see the bottle is getting much tighter, much firmer. And then we'll just heat it a little more in there, and the gas is even increased more volume. Alrighty, and then if we just let it cool just a little here, you can see that the gas is cooling again, and it already begins to contract. We shake it around, heat the gas back up. There, the bottle will get firm again. Okay, and like I said, if you use the bigger pop bottles, the effect is a little more dramatic there. And then we'll take it over to the cold water, and we'll just submerge it in there, and give it a second or two to cool down. If you have ice water, that's ideal too. You don't have to use a cold pack. That's just a little handy, a little less mess for you to deal with. And then you can show your students how the volume of the gas definitely did decrease as the temperature went down. The volume decreased. Now this water here is still a little bit warm. Let's see if we can warm it up a little bit again. I think we may have lost most of our heating ability of our hot water there. It's not going to come back. One thing you can do at this point, when you do have that decreased volume in there, the pressure will also have gone down, and that's the reason the bottle appears to have crushed in. The atmospheric pressure out here is greater now on the outside of the container than on the inside, so it's squeezing down, pressing down on our container. And then what you can do is slowly open the lid, and I'll bring it up here close to the camera so we can hear. You should be able to hear air rushing in to equalize the pressure there. So let's see if we can hear that on our tape here. There you go. And you can see that air rushed in and equalized the pressure here. Okay, the volume didn't increase because of any temperature change. It was because more air rushed in to the bottle there. All right, and then you can repeat the process. Take this water out and go again with another supply of the hot water there. So remember, be careful with this hot water so that you don't burn yourself. And again, we encourage you to only do this as a demonstration with your students. So this is one of the demonstrations for this lesson of Charles' Law, which is the relationship between temperature and volume of a gas.